This is the Severn Estuary. This is a set of images taken from the report on the Severn tidal power studies. It's a question about the Severn barrage. And I'm just using this as an example of the sort of complex problems which we're dealing with in infrastructure. The motivation to look at the Severn tidal power schemes was to look at generating green energy. But of course there are huge interactions with the environment, very rare worms which live on the bed of the estuary. Bristol port aiming, they started on I think it's about 500 million extension, so they can take the big Panamax containers. Very, very complex problem there, and that's sort of a good example of the sorts of issues that we are going to be dealing with over the next 50 to 100 years. But the important thing to realise about that is that if you look at all the people involved with dealing with a problem like that, there are thousands of different people, lots of different domain experts, all with different world views, different visions about what they're about, different sets of values and so on. And somehow, if we were to go ahead with some kind of a Severn tidal power scheme, we've got to bring all that thinking together. First of all, to generate a common purpose, so we know why we're doing what we're doing. And in this case, it's really about generating renewable energy, and things like flood protection and so on are additional benefits. But somehow, all the actors who represent those different domains have got to share their understanding and learn together. And really the thesis I'm going to put forward in my presentation is whether we are setting ourselves up properly to learn how to learn together. And this collective learning ultimately is building harmonised mental models. Everything we do is building a model in our brain, and perhaps we need to understand that better as engineers. We have a framework which we use in the Systems Centre here, which I just want to go through because it's about structuring learning essentially. We start off thinking about stakeholders, so we tend to look at needs-driven and value-driven activity. And those stakeholders exist within environments. There's a natural environment, there's social environments, and so on. And those environments are actually driving our needs, influencing our values, and so on. And coming out of those drivers are these needs, wants, and values, which we need to understand as engineers. And for example, coming out, if you're taking the Severn tidal power example, there's a need for green electrical energy. We, as professionals, interpret those high-level requirements into performance requirements for our infrastructures. So, for example, we might want to generate 30 gigawatts of electricity. That might be the design demand. And we come up with a system solution. So let's say it's a big barrage, or it's 7 or 8 nuclear power stations. In generating those system solutions, we need certain capabilities. There are lots of enabling technologies, processes, and people that we have to connect together to create that barrage solution. So, for example, we need expertise on the turbines. We need the capability to build sufficient bulb turbines. The main Severn barrage scheme will require 3 times as many bulb turbines as has ever been made in the world. A little procurement problem there. I mean, you obviously need the information about structures and concrete and all that sort of stuff. And those capabilities, those enabling technologies and so on, are underpinned by a body of fundamental knowledge. So, basic fluid dynamics, the maths, structural theory, and all the host of things which we have to know about. And then these things feed back up this chain, giving us the means to do things which eventually the system solution then satisfies those performance requirements, satisfies the stakeholder needs, but in doing so we have an impact back on our environments. This is a very useful framework that we've been using for a number of years now. It helps to identify where people sit within that hierarchy, what your role is, what your areas of expertise are. It also helps you analyse where the gaps are in the different levels of that. I should say that the bottom 3 levels here come from the National Science Foundation in the States, who use those lower 3 layers in the management of their research centres. However, I realised that what they missed off was the purpose and all the bit above it, which is really perhaps the most important part. But that's a framework for learning. It's a way for different people to connect their own understanding into a common picture and start to debate issues like the needs, the wants and the values. So we've got many infrastructure learners involved with these kinds of projects, very diverse knowledge sets and expertise sets, many different kinds of actors and organisations which are responsible for these. We've got to knit all this together. And we're doing it really to innovate. And for me, innovation is about connecting existing ideas together in new ways to create new value. Looking at this, this is a learning space. We're operating in a learning space. We need to understand whether we're shaping that learning space efficiently and effectively. And I'm not sure that we do stand back and look at engineering and everything else as a learning space. It's also an entrepreneurial space, and I use entrepreneur here in a very broad sense as somebody who is moving between sets of information and people, connecting them together to create value in different ways. So the domain experts and systems integrators and so on will be operating through those different layers, connecting ideas together. And if that space works effectively, then we've got a better chance of finding the innovative ideas connections. So I'm advocating that we should be looking at the way in which we work in terms of learning spaces and entrepreneurial spaces, and asking ourselves, are we setting ourselves up properly so we can do this kind of systems thinking, and I like the term systems doing. Now in education there are many different learning models, and this is one that I particularly like. It's called the accelerated learning cycle, put forward by a teacher called Alistair Smith, who used to be in Bristol many years ago, and it's quite widely used as a learning model in many schools. So many of your kids will have encountered this in their school education. And it's based on the understanding that the way in which we learn is through an iterative process where we're building mental models, connecting our neural networks together. And the idea is you go through cycles of learning, and each cycle of learning gradually builds your mental model, and the more times you fire it, the stronger and secure it becomes. And Alistair Smith devised this cycle which starts off with you recognizing you're connecting the current cycle of learning to what you did before. You then start with a big picture, setting the context. Contextualizing learning is fundamental to successful learning. If you don't understand the context, then it becomes very abstract. And only perhaps the Sheldons of this world in the Big Bang Theory will connect to it. We then describe the educational outcomes. So where is it we want to get to with this cycle of learning? We then have some kind of input. We get some information, get a presentation, a lecture, you go and do an experiment or something. And then you do something with that activity to learn. And then you have some kind of demonstration, write an essay, set an exam, produce a report for a client or whatever. And then you review it to decide what you need to do next. And that's a basic learning cycle. Now actually I think that maps very well onto what we do as engineers, because we're continually learning. In all our projects we're gradually building understanding. We're going through this kind of learning cycle. So to map these points onto the engineering process, a very simple mapping. The big picture is where we're setting out the environmental context and stakeholder needs, referring back to my systems level diagram. Describing the outcomes is where we're setting what the performance outcomes are that we're trying to achieve. The inputs is where we go and acquire information, share ideas, marshal it all. We then do something with it, we manipulate it, we model it, we put forward solution proposals and so on, and that's the really innovative part where we're connecting ideas. We then explain it and document it so we can share it and debate it. And we then review what we've done and then think about what we're going to do next. So there's a basic learning cycle there, which does map, I think, quite well onto the engineering process. Now here's an elaboration of that thought, which I'm working on at the moment. It's thinking about it in terms of infrastructure. We have a basic learning cycle going on here. It's recognizing that everything we do, we're connecting our learning together. If we look at these green blocks here, these are condensations of the more detailed steps within the accelerated learning cycle. We're starting off defining the purpose and performance requirements of our infrastructure. We then have a process which is dealing with conceiving our system, or acquiring information, thinking about it, designing systems. We then have an implementation process where we actually create the thing and operate it and so on. And we have a process of evaluation, which we're very weak on at the moment. We're very bad at closing the learning loop by seeing whether what we actually built does do what we designed it to do. And then we think about the performance, think about how we can improve it. And we can break down these processes into specific objectives, the sorts of things that we're doing. But at the centre of all this learning cycle is lots of information and knowledge and data that we're acquiring. And each of these processes is really dipping into this information, finding the right bits that we want to do our particular job to fit within the purpose. We do something with it, and then we put that information back into that knowledge base. Now I would suggest from the discussions we've already had this morning that we're not very good at connecting all that information together at the moment, because we haven't actually got a profession which has thought about how it's learning. And I think if we don't sort that out first, we'll end up continuing with this short-termist response. Whereas if we actually think about the professions and how they work together, how they work as a learning set of professions, that will help us enormously. Now, sitting inside here is a question then, how do we structure and marshal this learning environment? And I'm showing here some ideas about open systems architectures, which are capturing the principles of systems behavior, the generic principles, setting up protocols so we can connect ideas together more easily, capturing generic architectures which we can reuse, and the methods and data and models and so on. And one thing I would say, that open architectures does not necessarily mean open data or open methods. They can still be proprietary. So someone who's created that detailed knowledge can still hold it and get value from it. And there's an exemplar here, which is the IT sector. One of these things, memory stick. We've all got one of these. We all find them extremely useful. The reason why they're useful is that there's an open protocol for the USB interface that everybody knows about. It's accessible to everybody. But what that means is that SanDisk, who've made this memory stick, can build all the proprietary information they want within this product. But they know, because of the USB interface, when this is stuck into the computer will recognize it and will be able to access the proprietary value in the data stick. It's a very powerful paradigm. The internet is based on open standards which enable people to connect their proprietary information together to create value. And I would suggest that what the infrastructure industry needs to do is learn the lessons from the IT sector in particular and look at how we can open up our data and knowledge sectors in this open standards way so we can connect our information together more usefully. If we've got the means to do that, then suddenly collaboration becomes value-laden. If you can create value from connecting information together, entrepreneurs are likely to want to go into that. So, some questions I really want to pose to finish off. We've got a complex learning space. We've got a complex entrepreneurial space. And I would ask the question, looking at it from an infrastructure point of view, Is our current infrastructure space efficient and effective in terms of learning? I would say no. Is it really an efficient and effective entrepreneurial space? Once again, I would say probably not. Is it an effective and efficient systems thinking, systems doing space? And I think we've already said this morning it could do a lot better than that. And I think that then raises some fundamental questions about how the professions operate. We have a very structured set of professional institutions at the moment which have grown for legitimate reasons over the past 150 years. But are those actually structuring the way in which we do things in a way which isn't actually helpful? Does it inhibit systems thinking and systems doing? Our concepts of standards, do they need to change? We have rigorous codes of practice in construction in particular, which tend to ossify practice. It's very different often to go outside those codes of practice. And the business models are clearly need rethinking. And our purpose, I wonder whether we are too artifact-centric in our thinking, whereas in fact what we should be doing is being service-centric. What is the purpose of the artifact that we're trying to create? And changing our thinking. And just to finish off, when I did my undergraduate degree, which was now 40 years ago, it's 40 years ago this year that I started my undergraduate degree, I did all my calculations on one of these things. I showed this to my daughter, who's a natural science graduate from Cambridge, and she didn't believe that you could multiply and divide and do logs and things like this. That was 40 years ago. 40 years ago, we had no real concept that we would find one of these things essential. That's over 40 years. We have really no idea what sort of technologies are going to be around in 40 years' time, but we're going to go through these kinds of leaps. So we must make sure that the way in which we operate as a profession allows us to make those kinds of leaps efficiently and effectively. So I'll leave that thought with you.